imagination go? What else?
Find outliers in your data.
Well, it's part of this descriptive statistics that we have. Yeah. In a way, yeah, that relates to this. Not this, not another one. Diagnostics, so these are the classification problems. Well, I got something to do with profilin levels predict the cancer state or something. I don't know. So you want to classify based on some variables or
like
your classification of potential preeclampsia, people going to get or not going to get. That's classification basically. This bin or that bin or multiple bins. So those kinds of classification. They're related to the group. The second point here, kind of related, but you develop certain tools so that you can, based on certain measurements, you can classify somebody being in group 1, group 2, group 3, group 4. Those are biologically relevant, if you think. Low risk of cancer, medium risk of cancer, high risk of cancer, something like that.
It's kind of sensitivity.
Yeah, so then once you classify it, then you say your tool, how good it is. So the measures of goodness of your tool to classify are sensitivity, specificity, positive predictive ability, and so on. Those are the measures of its goodness of that tool. But anyway, so the certain discussion can go on there. That comes under classification. I'm just going to give you a feel for overall feel. And this is what is the design of experiments, outliers and stuff. Afterwards, also you can sample size and so forth. Also, some particular design you have enough properly designed groups based on what you're trying to do.
But that also depends on the variability, right? So you need some initial estimation what your natural variability would be, right?
But it allows you to design an experiment, including the actual constructs of what groups and what treatments you will be doing depending on that. So statistics will help you there, and then maybe some other stuff. So I think it's useful. Basically, that's not just providing data, just a bunch of data. It's like what was the good analogy? Knowledge versus information. Yeah, that's exactly. A ton of information available on the web, but that necessarily is not knowledge. What's the difference between information and knowledge? Information is just like data, raw data. It's just there. And there's millions of pieces of data, but knowledge is when you synthesize that and sort of compact into digestible units, and then you infer something from it. It's knowledge. Okay. So we just talked about population versus sample. One of the key things that keeps coming over and over: randomly selected data points or observations, independent observations, and randomly selected observations. So I thought maybe we just spend a little bit of time. That when we do our experiments, those data points that we're going to use to calculate mean standard deviation or use in comparing groups. So what constitutes independent observations? Randomly you can see, because you're not giving preference to something, as much as possible. It's chosen randomly. That's what's independently chosen. What constitutes independently chosen? So, this question, Partha and I discussed this several times, and it actually in the molecular biological area, it's quite common. Let's say in physiology, if we wanted to so here's an example, and the answer is quite clear. I wanted to know cardiac output in dogs. What's a normal cardiac output in dogs? So I will clearly go and make cardiac output measurement in 10 different dogs, right? I won't make the 10 cardiac output measurement in a single dog, right? For that, you go 10. That's pretty obvious, right? And so 10 measurements made in a single dog, you would not call as independent measurements, correct? So it's very, very clear, and it's intuitive, right? But I don't know. Maybe Partha, you can give an example from the time, that measurements. Pick something. Let's say from one slide versus take a concrete example. That way it becomes really real. Just so that remember you had a question whether n should be all those measurements I made for one slide, or should I do some?
I remember that. Okay, so the question is, in a way, we shoot movies of cells. We analyze movies of. We take these migrating cells, and for each cell we calculate the average speed, right? So for example, in one experiment we analyze for a given condition, experimental perturbation, 30 cells, okay? We repeat that experiment, another 30 cells ago. Repeat another experiment with another 30 cells. So the question is, when you do a summary statistics and a standard deviation, would you call the sample size as 90 because you analyze 30 and you pool from all 3 experiments, or would you call n equal to 3? Right? That was the question we had.
Right.
We always like to do it n equal to 90. That's what
That's okay.
brings the standard deviation down, obviously. So what is an independent?
So everybody understands, right? He is using the words experiment simply to indicate maybe today you made measurements, but tomorrow you're going to make exactly similar not exactly same.
Yeah.
Similar types of cells, similar type of experimental conditions, everything same. But do the 30 measurements of velocities of movement, and within each measurement, these cells, they reside on a cover slip or something.
Or in a dish. I mean,
a dish.
So in our case, we think we justify each cell as an independent sample because on one dish, all those 30 cells are not exactly in the same state. Right? That's number one.
So first of all, I would say there's no statistics or statistical rule is sitting there giving you an answer. The answer has to come from you. So the question you ask yourself is that are those 30 measurements independent of each other, or they're in the sense behavior of one cell in that group of 30 cells, do you have any physical, biological reason to say that affects the behavior of the other cell in that group of 30?
Yeah.
If we have that, see for example, clear example would be you're making some measurements where these are confluent cells. They
Right.
and that they talk to each other, and whatever you're making measurements, by biology they get affected. Right? If it is, then there's really no reason for you to say that these are not independent. I mean, what this one cell does, which is your measuring, in this case velocity, is not necessarily the other cell gets affected by that. So,
At least in a macro scale.
yeah. So if you have enough faith in that, then go ahead and use those 30 measurements. Just because you did it in that day doesn't make them magically into one sample. So this is a difficult proposition, and there is really knowing what is going on and just